Hello students, our next topic is chemical properties of amines. Up till now we know that we are going to study few laboratory tests, okay, and then we are going to go for the important test. So the laboratory test there where we are going to check whether the given compound is amine or not, and that's why uh, first of all the first test is the litmus test. Okay, we know that the litmus test, when blue litmus turns red, we are going to say the compound is acidic in nature. When red litmus turns blue, we say the compound is basic in nature. And we know that the amines are basic in nature, means definitely red litmus turns blue is the observation. So all amines, that is the primary, secondary and tertiary, are basic compounds. Aqueous solution of that is then water soluble amines will show us the red litmus turns blue. Okay, so this is very common, very general thing is there, but to try to understand in the chemistry's nature, we have to swallow this morsel in another way. Okay, उलट्या हाताने घास खाऊन बघायचा आहे आपल्याला इथं. सो फॉर दॅट व्हॉट वी आर गोइंग टू डू, दिस amines is going to treat with the acid which is aqueous. This is very important, means water is there. Then we get this water soluble solution and Cl minus separated out. Okay, then next we, as we are adding here HCl, then we are going to add NaOH to neutralize this solution. Just for a time being, we don't know what is the given organic compound, but we are treating it like this. Okay, just think like that, and then we are going to neutralize this solution whatever there by the NaOH. Means after neutralization there is formation of salt, but still if you are going to use red litmus and if you are going to put this red litmus in this solution, then it turns blue. Means what? The main given organic compound is basic in nature, and then we can say this is nothing but amine. This is nothing but amine. Red litmus turns blue, means this is nothing but amine. Okay, by pouring or by dipping red litmus into the given solution, it also turns blue. But again, to understand all the chemistry about this basicity and acidity, we have to add plus aqueous HCl. Then we can have this mixture. In that mixture we are going to neutralize with the NaOH. After neutralization we will get NaCl, which is also in aqueous nature, and whatever the compound in that, it shows basic character, means red litmus turns blue. Okay, and so this is known as litmus test. Okay, so now next one, this is very important, and which is we are going to study in laboratory also, and the video on this you are going to see it very soon. That is the diazotization reaction. Diazotization reaction, this is a new word for you. In 12th standard we are going to listen this word diazotization, and this test is also known as orange dye test. This is also known as orange dye test because product is look like an orange dye, and this is also called as diazo reaction. This diazo we can separate as diazo reaction. Okay, diazo is nothing but two nitrogens connected to each other, that is diazo. Okay, or diazo, this is the thing, two nitrogens connected to each other like this is the diazo. Okay, so what is this reaction exactly? First of all we will take aniline. This is our aniline, aryl amine C6H5NH2. We are going to add here HCl. In laboratory, theoretically it is given as a concentrated HCl, but in the laboratory we use dilute because this is a very exothermic reaction, and to minimize the effects of the exothermic reaction we use here dilute HCl. Again we can have to cool the solution, that is the another thing, and basic medium is required, so we added NaNO2, that is sodium nitride. This is our sodium nitride. Okay, so what is going to happen? See, this is the very complex mechanism. Okay, but to try to understand at the 12th standard level, I am just going to simplify it like this. See, this CCH5NH2, this is the aniline reacting constant diluted Cl in presence of NaNO2, and there is formation of C6H5N2 plus, remember this very well, N2 plus Cl minus, N2 plus Cl minus. Okay, so what is going to happen here? See, and byproduct are H2O and NaOH. Byproduct are H2O and NaOH. See now, try to understand this reaction in the very simplest way. We are not going to go detail with the mechanism because that is difficult to understand in 12th standard. So just see here what is going to happen. This is C6H5NH2 reacting with HCl. This is our C6H5. Okay, here it is one nitrogen and here it is one nitrogen. From this NaNO2, here it is one nitrogen. One nitrogen from here, one nitrogen from here, it becomes N2. It becomes N2. Now here it is, this Cl is over here with the negative charge. As this lone pair of electron is donated, this nitrogen's lone pair is donated, so it acquires, one nitrogen acquires positive charge, and to balance this there is Cl minus. Now what is remaining? Remaining one is two hydrogens here, one hydrogen here, then here it is sodium and two oxygens here. And so with these three hydrogens, here it is two hydrogens used for preparation of water molecule, while one more hydrogen attached to this O, one O which is remaining, and there is formation of NaOH, and this is the byproduct H2O. Are you getting this thing? C6H5, C6H5. One N from here, one N from NaNO2, there is formation of N2. Then Cl from this HCl over here. Now what is remaining? Remaining one is two hydrogens from aniline, one hydrogen from hydrochloric acid, and one sodium and one oxygen from NaNO2. Okay, so sorry, two oxygens. So one oxygen is going to form H2O with this H2, one O, so there is form H2O. Then now Na and one O is remaining and one H is from here. So totally this Na, one O from here and one H is from here, formation of NaOH, formation of NaOH. And whatever we get is known as phenyl diazo. When there are two nitrogens, di means two, azo means nitrogen, is known as diazo. This is having positive charge, so this is ion, म्हणजे ion is there. So this is diazonium, and chlorine with negative charge, so this is diazonium chloride. This is also called diazonium salt. All of you know that Na plus Cl minus, plus and minus gives you salt. Similarly, this plus and this minus. So this is also called diazonium salt. Okay. Now what is the next step? Next step in the laboratory, we are going to add beta naphthol in NaOH. This is our beta naphthol, and we have to prepare beta naphthol solution in NaOH, which called as beta naphthol. This is the beta position. This is alpha position. So this is on the beta, there is OH. So this is beta naphthol in NaOH. Now what is going to happen? This C6H5N2Cl. Now I am writing this C6H5 in the form of benzene ring. This is the phenyl group. Okay, phenyl group C6H5. One of the H is replaced by N2Cl. What is this? N plus triple bond NCl minus is going to react with beta naphthol in NaOH. We have to cool this solution. And what is going to happen? See now here. See here. Here it is at the alpha position. Here it is at the alpha position. Okay. There is one H. There is one H. And this H is substituted by the whole phenyl diazonium this Cl minus is going to separated out from here, and this H and this Cl minus, this H and this Cl minus is going to form this HCl. This H and this Cl minus is going to form HCl, and this is going to substituted at this position. This is going to substituted at this position. There is a formation of bond in between this N and this C, this N and this C. So here it is the formation of bond N, and here it is the C, and remaining. So this triple bond is converted into double bond. This positive charge is going to vanish. So there is no positive charge on this N. This is just N double bond N, and this benzene ring we are writing here C6H5 and the beta naphthol as it is. When such a type of compound, complex compound is formed, it shows orange red color, which is nothing but dye, which gives color, orange red dye, and so this is also known as orange dye test. Orange dye test, diazotization reaction, diazo reaction, or here it is the coupling in between. Coupling in between this, coupling means they are going to attach to each other, this benzene ring as well as this benzene ring, and so this is also called coupling reaction. This is also called coupling reaction, and in this way we get this orange red dye. Now next one is alkylation of amines. Up till now so many times we heard this word alkylation. It is nothing but when the alkyl group is attached, then that is known as alkylation of amines, and this is specifically Hofmann's exhaustive alkylation. Exhaustive means in a large quantity there is alkylation. This is exhaustive, very exhaustively this is going to happen, means their strength, their quantity is more. So that is exhaustive alkylation. Okay. So addition of alkyl groups. Alkylation is nothing but addition of alkyl groups. When a primary amine is heated with excess of primary alkyl halide, it gives a mixture of, see, it gives a mixture of, what is that? Mixture, primary amine gives mixture of secondary amine, tertiary amine, secondary amine, tertiary amine, along with tetraalkyl ammonium halide, along with tetraalkyl ammonium halide. So this is our primary amine reacting with excess Rx, alkyl halide. Now here we are going to remove HX, so we are writing here minus HX. Here also we need basic medium, so we use sodium bicarbonate. Then here it is formation of one of the H is replaced by R. So here it is formation of RTNH while HX is removed. In the next step again another molecule of Rx is going to react, HX is removed, and there is one H is again replaced by this R, H is replaced by this R. So now here it is R3N. Again here lone pairs are available on this nitrogen. So it is again going to react with this Rx. These lone pairs are going to transfer or share with this another R, so which is total now 4R. So N acquires positive charge while this X, there is no HX formation like this. So this X attached here and it acquires negative charge, and here it is formation of tetraalkyl ammonium halide. This is tetraalkyl ammonium halide, which is salt, plus minus, which is salt, which is the major product. This is also called as quaternary ammonium salt, quaternary ammonium salt, and it is solid in nature. It is solid in nature. Crystalline solid we get when there is formation of quaternary ammonium salt. So what is exactly happen? See here, with the primary amine it acquires 1, 2, 3. So 3 moles of alkyl halide converted into tetraalkyl ammonium halide. When we are going to consider secondary amine, 2 moles of alkyl halide, 2 moles of alkyl halide converted into tetraalkyl. When it is tertiary amine, only 1 mole of alkyl halide and it is converted into tetraalkyl ammonium halide. And this explanation I just given you in the form of the reaction, which is given in the description in our textbook. So, 3 moles, 2 moles and 1 mole. Okay. Before this we studied the reactivity is RI is more reactive than RBr, RBr is more reactive than RCl. We studied this thing before this. Okay. So, based upon that, the example we have taken is with alkyl iodide. This alkyl iodide, that is why we use here I. We are not going to take example with bromine or chlorine because reactivity of Ri is more. So, the example is with this. Okay. Why not Br, why not chlorine? Okay, this is the reason. This is more reactive. Okay. For example, a very simple primary amine we have taken, this is the methylamine reacting with CH3I. This is exhaustive methylation now. This is exhaustive methylation because methyl group we are going to add. First reaction 2 CH3, third reaction 3 CH3, fourth reaction 4 CH3, and now we using lone pair of electron of this nitrogen, that is why this nitrogen is having with positive charge while I is with negative charge. We can take another example also. This is our ethylamine CH3 CH2 NH2 ethylamine, which is also primary amine. Again exhaustive methylation we are going to treat with the methyl iodide. So, now here what is going to happen, see, one of the H from these 2 hydrogens is replaced by CH3. So, remaining now only one hydrogen. Again this is going to react with this compound. So, this H is replaced by CH3. So, now here it is CH3. This CH3 is as it is, this CH3 CH2 is as it is. These two groups are as it is. Only this H is replaced by CH3. And what will be the next? Again very simple, this nitrogen is having lone pair. So, this is going to share with the another CH3 and so now total there are, here it is, this N is acquiring positive charge, one more CH is attached. So, we are writing here 3 CH3, 1, 2 and 3. This is